Greetings, fellow teachers. My name is Tom Love. Welcome back to Basic Mathematics using the Garden Approach. This session will be on integers or sign numbers. Integers, called sign numbers, have positive and negative in front of them. That's why they're called sign numbers. Integers are critical numbers because they basically are a transitional number between arithmetic and algebra. Now, they are not one of the fundamental 8 numbers that arithmetic talks about, but they are an important number because this is the one thing that many students have trouble with when they start algebra, and this makes them drop out of algebra or have trouble with algebra or hate mathematics, which we don't want. So it's important that we start here giving students a very good, successful experience and have them gain confidence in integers and find out they aren't that bad. Now, of course, the more exposure they have to integers, the better off they're going to be. So it's good that we start here with integers, and when they get to algebra, they'll be old friends with them. All right, well, let's get started here with integers or sign numbers. All right, integers or sign numbers can be represented on the number line, and if they're positive, they're on the right side. If they're negative, they're on the left side. Now, some real-world examples of integers where they are very helpful is temperatures. Above 0 would be positive, below 0 are negative. Financial values, if they're assets, they're positive. If they're liabilities, they're negative. And sea level. If we're above sea level, we're positive. If we're below sea level, we're negative. So there are a lot of places where integers work in the real world. Now, let's talk about addition of integers. With addition of integers, we have a couple rules called principles here we have to abide with. If we have a positive 3, there are 3 positive signs associated with it. If we have a negative 4, there are 4 negative signs associated with it. And the rule of opposites is if we have the same digits with positive and negative signs, they cancel out and give us 0. Here we have the same digits with positive negative signs and we end up with 0. So they sort of cancel each other out. Now, if the signs are alike, then we just add the numbers and keep the sign. If the signs differ, then we apply the principle of opposites and cancel them out. So it actually turns out to be fairly easy. All right, let's get started here and see if we can apply these rules and these concepts to integers. Now, of course, I said concepts there. Students not only should be able to operate with integers, but they should look up integers in the textbook and write out the procedures and the rules for addition of integers and then provide examples. And these 4 examples that I have in little groups are critical examples for them to learn, and as I'll point out later. Now, in the first problem, we have a positive 2 added to a positive 9, and it gives me positive 11. A negative 3 added to a negative 7 gives me negative 10. Now here I've got opposites. I have 4 positives and 8 negatives. So the 4 positives cancel out 4 negatives and I end up with 4 negatives left. Here I've got opposites. I've got a negative 5 and a positive 6. So the 5 negatives cancel out 5 positives. I end up with plus 1. Visually you could represent it for a student showing that these are the 5 negatives. These are the 6 positives, and it's very easy to see that the 5 negatives cancel out 5 of these positives, and I'm only left with 1 positive. All right. Now, you could hit the pause button now and go ahead and do these problems and catch up with me, or I'll try to slow down just a little bit and you can stay up with me, but I'm sure you're not having any trouble with these at all. Now, here we go. Here we have a positive number and a negative number. Now, the signs are different. So the 3 positives cancel out 3 negatives, and I end up with minus 3. Here we have different signs. We have negative 2 and positive 8. So the 2 negatives cancel out 2 positives, and I end up with plus 6. Here the signs are the same, so I end up with plus 12. I just add the numbers and keep the sign. Here they're negative, both of them, so I end up with minus 13. But do you see the problems are set up in groups of 4? Here, the negative number was bigger. Here, the positive number was bigger. Here, they're both positive, and here they're both negative. These are not random problems created. I created these and designed these to make sure that all possibilities of signs were addressed and worked on. Students working on these groups, and we will have plenty of activity sheets for them to work on these groups, will nail the operation of addition after they work on it. Well, let's proceed on here and look at subtraction. Now, subtraction uses the same rule of signs, that 2 positives would be associated with 2 positive signs and 3 negative be associated with 3 negatives. The rule or principle of opposites says if we have the same digit with opposite signs, we get 0. They cancel out. And if we have the same digits with opposite signs, they cancel out. Now, here is the procedure to subtract fractions. You change subtraction to addition, then you change the second number to the opposite and combine them like you would an addition. Boy, that sounds confusing, doesn't it? But now watch. Let's go back to basic mathematics. If I was to give you 2/3 divided by 4/5, what would you do here? You would change division to multiplication, 2/3 times, and you would change the second number to 5/4. My golly, that's almost identically to what I'm asking you to do here. And of course, then you would just multiply and you'd get 10/12. You can see that the procedure to multiply or divide fractions is exactly the same we're doing here with subtraction. And to help you with this, I can cut this procedure down to 3 simple words. Always think about when you're subtracting, what you want to do is you want to add the opposite. If you remember those 3 words, you can get through this without much trouble at all. All right, now here we go. Here's a subtraction problem. I change it to an addition and change this to the opposite. So now 2 positives cancel out 2 negatives and end up with -7. I change this to addition, change this to the opposite, and 3 negatives cancel out 3 positives, and I end up with 3 positives left. I add the opposite, and I end up with +10. The signs were the same. I add the opposite, and I end up with -12. The signs were the same after I did that. Fairly easy, right? I want to add the opposite or do something very similar to what I did when I did these fraction problems. Boy, I'm a messy writer. All right, now, if you want to hit the pause button and go ahead and work on these problems and catch up with me, that's fine. I'll try to stick to a immediate speed here so that you'll be able to stick with me if you want to. All right, now I'm going to use these 3 simple words to help me do these problems. I'm going to add the opposite, and of course I have like sign, so that's a +9. I'm going to add the opposite, so I end up with -10. I'm going to add the opposite, whoops, they're different here, so 5 positives cancel out 5 negatives and I end up with -2. I'm going to add the opposite, and 4 negatives cancel out 4 positives and I end up with +5. Do you see? Set up for success. If the student does these 4 types of problems, they should be able to own subtraction, and if they use this special little quick and easy procedure rule, that'll even help them with it. And of course, if they have trouble accepting the procedure, mention that they didn't have any trouble with fractions, so why should they have it with integers? All right, now multiplying integers, no big deal here. The rule of signs is the same, the rule of opposites is the same. Now the procedures, if the signs are alike or if the signs are the same, multiply the digits and the result is positive. If the signs are different, multiply the digits and the result is negative. Now, one of these problems is really going to bother you, but if you stick to the rules, you can get it done. All right, now here we go. All right, now these 2 signs are the same, so I multiply them and the sign is positive. These 2 signs are the same, so I multiply them and get a positive. Now, I paused for a minute there. That might have bothered you, because how in the world am I going to get a negative, 2 negatives to give me a positive? Well, the rule said if the signs are alike, multiply them and the result is positive. Now, actually, you can understand this if you go back and look at subtraction, because multiplication is repeated subtraction, and repeated subtraction will basically make this become a positive 24. All right, now, here we go. These signs differ, so I get a -28 when I multiply 4 times 7. These signs differ, so I end up with a -30 when I multiply these digits. So, hey, no problem at all, right? We just follow the rules. Hit your pause button if you want to work these out and catch up with me. Otherwise than that, here we go. The signs differ, so I've got a minus 18. The signs differ, so I've got a minus 14. The signs are the same, so I get a plus 40. And the signs are the same, so I end up with a plus 36. You really need to work on this one and make sure your students are following the rules and getting this one. That is the one that they'll have trouble with. All right, now, dividing integers. Again, always with the rule of signs, always with the rule of opposites, and the procedures are just about the same. If the signs are alike, divide the digits and the result's positive. If the signs differ, divide the digits and the result's negative. Basically the same thing, isn't it? All right, so the signs are the same, so I get a plus 3. The signs are the same, so I end up with a plus 4. And again, this bothers some students, but they have to get over it. That's the one stumbling block that integers really, and this is so important when they get into algebra. Now, the signs are different, so I get a minus 2, and the signs are different, so I get a minus 5. Do you see there? It was a simple division problem. Boy, integers really reinforce multiplication and division and addition and subtraction facts. So if the students don't have the facts down well, you can see where they're just swallowed up in algebra and completely just fail it. And they need to be able to accept rules and follow them. And of course, they're explained later on in extended concepts. But the signs here, when they're differ, can be explained very easily by adding the opposite, just like you did when subtracting. All right, now if you want to hit pause and catch up with me, otherwise than that, here we go. The signs differ, so I get a minus 4. The signs differ, so I get a minus 2. The signs are the same, so I get a plus 3. And the signs are the same, so I get a plus 5. Do you see I set up these problems so that they're very simple. The students only have to think about what the answer is, because the division comes out real easy. And do you notice here we've got a plus and a minus and a plus and a plus, and a minus and a minus. That's the only combination of signs you'll ever run across. So if you learn these problems in groups, you will own integers. They will be your friend. All right, now let's talk about absolute value. Absolute value basically talks about distance on the number line. And basically, distance is always positive, whether it's to the left or to the right. Now, the absolute value of a positive 3 is 3, because we're talking about distance here. Now, the absolute value of a negative 2 is 2. And the way that works out is you add the opposite, and basically you end up with a plus 2. Nice and easy. Here are some very nice ways that abstractly those particular rules are explained, and students may look that up. But basically, if they look up this concept of absolute value and get a simple definition, restated or paraphrased, and then present some examples, just like we have some nice simple concrete examples here, then they have fulfilled the obligation of knowing how to read, write, and talk mathematics, especially absolute value and integers. They might be able to apply the skill, but they need to be able to write out the definition and present examples. Now, comparing values. When you compare values, you want to make sure that you always change from the absolute value to the integer, and then you compare them to see what the value is. Now here, very simply, obviously the 6 is bigger than the negative 2. If I take the absolute value of both, these are both positive, so the 9's bigger than the 3. Here, if I take the absolute value of that, that becomes a positive 8, and it's bigger than the 4. All right, and just looking at that, if you didn't change it, you could see that students may get confused with that and think it's a negative 8. All right, now here, of course, the positive 2 is bigger than the negative 5. Now, you might want to go ahead with these problems and put on your own less than and greater than symbols, or you can hit pause and go ahead and do it and catch up, or you can stick with me here. Now, the negative 28 would be more negative than the negative 7. Here, that becomes a positive 12, so that's larger than the negative 6. Here, I take that and take the absolute value. That's positive, so it really stays the same here. And, of course, the negative 16 is less than the negative 8. So, no big deal with comparing values with less than and greater than. Later on.